Hello, and welcome to my Lab 8 video demo. In this lab, we're going to be demonstrating network-based communication between field devices and a networked system, such as with the field device being this microcontroller, this Nano ESP32 controller board, and a MQTT broker, which I will be using Hive MQ as my broker. Basically, so the idea is my my microcontroller will be acting as a sensor node that will be sending and receiving messages. It's going to be sending our raw analog. It's going to be converting our raw analog input data from this potentiometer, and it's going to convert it into a percentage, which will then get sent over to our broker. Our broker is going to take that data and it'll take that percentage and we'll be able to view it sort of like an HMI system for monetization. And then we also have an LED hooked up to our sensor node. Based on the commands from our HMI system, our controller will be receiving those commands and changing the behavior of our LED output based on those commands. Just a little bit about this broker. I'm using Hive MQ. This is just a free broker that is available. Because this broker uses TLS encryption, in order to use it with Arduino IDE, you're going to have to create some credentials and implement it into your code, which I will demonstrate later on once we go into the code. So I just made a simple password, test user, and a simple username named test user and a simple password. Web client here is going to be for our HMI, so I'll just go ahead and sign in right now. You can see we're connected now. And then before we start using that, I will go through some of the code. So here we have a couple of libraries. We have our Wi-Fi library for communication from our nano board, because our nano board also needs to be connected to the same Wi-Fi. And we have our Wi-Fi client secure, which is basically adding your network username and your network password for your personal Wi-Fi. So I have my Wi-Fi here and my password, which I've taken off. And then we have this variable here, MQTT server. And this basically here is our IP address, which is for Hive MQ is just a URL. We have our port that we're connected to, and then we have our username and password here for our broker. A couple of telemetry data, a couple of topics that we must subscribe and publish to. Once we get into our controller, we'll start to use those. Here we're setting our potentiometer to the analog pin, which is A0, and we have our LED set on pin 5. We have our last published time variable, basically used in the loop function. It's always checking for when the last message was published. And then a message gets published every 5,000 milliseconds, which is 5 seconds. I'll go into that a little bit later of why I chose 5 seconds. Here we have our credentials for Wi-Fi, making sure that it's connected. And then a couple of functions, connect to Wi-Fi, basically making sure we're connected to Wi-Fi, connect to MQTT, making sure we're connected to our broker, our MQTT callback. excuse me, which is basically connects the ESP32 to our broker, and this function basically runs whenever the ESP32 receives a command from our broker, and then it checks for a message. It checks for the commands of on, off, or blink, which is the 3 commands that I have implemented into the code. Publish telemetry. This allows our data to be published on our HMI systems and our serial monitor. Handle output function basically handles all of our commands on, off, and blink. And then our read sensor percent is what converts that raw analog input reading into a percentage. Here in our setup, the ESP establishes the serial monitor connection, sets the sensor pin, our potentiometer as an input, and sets our LED as an output. Here in our make sure we're connected to Wi-Fi and our credentials are correct. And then same with the broker. In our loop function, the program's constantly going to check if Wi-Fi and connection to the broker is secure or connected. And if the connection is lost, if it reaches if the last published message takes longer than the interval, then it's going to put out that the connection was lost on our serial monitor. Oh, sorry. Make sure we're connected to our Wi-Fi. If not, print out on our serial monitor that the network has been disconnected and that there's an error, there's an issue. When we're connecting to our Wi-Fi, it's going to throw out the IP address. And then making sure we're connected to our broker on connect to MQTT function. Making sure our credentials are correct as well here in this string. The topics that we're subscribed to, it'll put out those on our HMIs. And then our callback function is always checking to see what commands are being receiving, always checking what commands are being received so that they can display in our serial monitor. Here's our on, off, and blink functions, commands. And then we have our published telemetry. This function is gonna say level or what output mode we're in, and it's gonna display that on our HMIs as well. Here's our read sensor percent. And then we have our last handle output function, which deals with the timing for the blink command. Basically, if we send a message, if we publish blink, it's going to blink the LED every half second. And yeah, that's it. So let's go ahead and demonstrate what that looks like here. Pull up our serial monitor. Pull up our serial monitor so we can see. Connecting the board. Serial monitor. Let's do that one more time so that we can see connection being made. Connecting to Wi-Fi. Network disconnected. Oh, I'm sorry. Oh, there it is. Wi-Fi connected successfully. There's the IP address. Connecting to broker. And now it's putting out that telemetry data of our potentiometer percentage and what output mode we're in. Every 5 seconds. go ahead, I'm already signed in to our broker. Subscribe to our telemetry topic so that we can see the percentage and what output mode we're in. I will go ahead and send our first command of on for our LED. We will send message. LED turns on, and we are able to subscribe, and now we are able to see what our telemetry is putting out. And we're also able to see that the command was received on our serial monitor. We're change potentiometer level. Go halfway about. You can see that the level went up. We'll go all the way to 100. And we're at 100. LED is on. Now we will publish blink mode. We'll send that message. LED now blinks. Telemetry has been received that we are in blink on both serial monitor and HMI. And now I will do my last command of turning it back off. And the LED turns off. Command received, off. And then one more thing I wanted to demonstrate is the idea of the network-based communication, with this being the broker. As long as we have our IP address, or in this case our URL, we're able to influence this controller from any remote location. I'll put in those credentials. And connect from MQTT Explorer. This would simulate another HMI in your facility or any other remote location, as long as you have the broker IP address and you have access from the owner. You are able to either view or control the outputs connected to that device. So we have blink, and we are now blinking. Going back to serial monitor, it also received that telemetry. We'll go on, and the LED stays on. Let's see what it looks like in HiveMQ in our main broker. It also received that telemetry. And the nice thing about HiveMQ is that you can add credentials. You can give anyone credentials and give them limited access. They can view only or command only, publish, subscribe. This truly demonstrates network system communication, network-based communication. I publish and subscribe to structured data topics. And then lastly, I wanted to demonstrate a disconnection from the broker or even from my Wi-Fi. I'll go ahead and just delete this broker here. And the broker no longer exists. And now oh, I guess I gotta sign out of this one as well. So we'll turn the LED off. Oh, we are disconnected from the server. And you can see it took a minute, but the network disconnected from the broker. MQTT connection has been lost. And we now have a failed connection since that broker no longer exists. And our LED is stuck in on mode. All right, thank you for watching.